Okay, this is passage 5, and I like the look of it. The graphs look fairly similar, and they do this a lot where they'll give you a little diagram and then they'll give you a couple of graphs. Anywho, let's get right into it. I'm just going to read the first little bit that's before the diagram just to get an idea of what we're talking about. And it says a zinc-air battery, a ZAB, produces an electrical current when oxygen, O2, in the air flowing into the battery reacts with zinc metal to produce solid zinc oxide. We get a chemical equation. 2 experiments were done using the apparatus shown below. I don't care. For each trial, steps 1 through 5 were followed. I'm not going to get into that. I'm just going to go straight to the questions. Based on the description in step 1, okay, so that's going to be the first thing we have to do is find step 1. What was the total voltage? What was the total voltage that was produced by the stack of batteries in each trial of the experiments? Okay, so number 2 will be find the total voltage of a stack of batteries. Right, so the first thing I have to do is find step 1, and I see it here. These are steps 1 through 5. And step 1 is this one. 3 1.4 volt batteries were stacked, okay, in a series so that their voltages added together. Okay, I think that's the important part. In the airtight chamber, each battery was either a ZAB or that doesn't really concern me. Okay, so it says what was the total voltage that was produced by the stack. So a stack, we add the voltages. So what do we have? We have 1.4 volt batteries, and we have 3 of them. So it's 3 times 1.4, and that's 4.2. That's G. Right, number 25. If trial 4 had been extended, at approximately what time would 0.45 milliliters of oxygen have reacted? So we need to find trial 4. Extended, we need to extend it, and then we have to look at that's 2, and then 3 is find 0.45. Right, trial 4. Where is trial 4? Experiment 1. 3 trials were done, so that's trial 1, 2, and 3. Okay, experiment 2 then has trial, yeah, there's trial 4 there. Alright, so say trial 4 was extended. And this is called an extrapolation question, and it just means you carry the line on beyond where it stops. So it's in a straight line, so we can confidently say it would extend to about there. Then, so we've extended it, we've done 1 and 2, we've found trial 4, we've extended it. Then we have to find 0.45 milliliters of oxygen and then get the time. So that would be, the time would be step number 4. Okay, we've extended it. We need the oxygen reacted, the O2 reacted, it's up the side here. We need 0.45, that's it there. We've extended it to just short of 250. But if you draw the line down here, so this would be the time, so it's just short of 250, and 240 would be the answer, C. How many SLBs, if any, were tested in experiment 2? Okay, experiment 2, what did it do? Experiment 2, in trial 3 was repeated in 2 trials, except that in trial 4 the current was 10, and in trial 3 and 5 the current was 30. So experiment 2, it repeated trial 3, so we have to come back down to experiment 1 here and find what trial 3 did. And we look down here and we see that trial 3 had 3 ZABs. Nothing else. It just tested these ZAB batteries. So it didn't test, that means that none. How many SLBs? There was none. So that would be F. Okay, 27. A chemist predicted that the volume of O2 reacted would increase. The volume of O2 would increase at a faster rate if the number of ZABs present in the stack of 3 batteries were increased. Do the results of trial 1 and 3 support this? Alright, so step 1 will be find trial trials 1 and 3. Step 2, we're going to have to look for the volume of O2. Will it increase if the number of if the number of ZABs increase? Okay, so trials 1 and 3. Let me find that. Oh, I'm losing my bearings. All right, so these are figure 1 has trials 1 through 3, so we've done the first step. Volume of O2 reacted is up here, and he says it would be faster if the number of ZABs. So this figure doesn't tell us anything about ZABs or SLBs or anything. The graph doesn't. So we're going to have to read. That's all that's telling us. If you don't find it in the graph, you're going to have to read the experiment information. And it says 3 trials were done. Right, we need trial 1 and 3. In trial 1, we had 1 ZAB and 2 SLBs. Trial 3, there were 3 ZABs. So trial 3 had more ZABs. Okay, we'll come back up to the graph. Trial 3, this is the one that has 3 ZABs. You can see this gets to 40 in only 100 seconds. Trial 1, which only has, I think, 1 ZAB. It has less ZABs, I don't know if it's 1 or 2. To get to 40, it takes 300 seconds. So 3 ZABs produce the oxygen faster. So he predicted that the volume of O2 would increase at faster rate. It does, right? We saw that here. With 3 ZABs, the more batteries, the ZAB batteries, the faster it goes. So the first part of it is, yes, he's correct. His hypothesis is correct. So that means anything that has no in it is gone. Now we just have to find the right answer. And it is, A says yes, because the final volume was reached sooner. Yes, it was. It was 100 seconds versus 320. In trial 3, yep, than in trial 1. So that's answer A. Okay, question 28. Based on the chemical equation in the passage, I hate chemical equations. In a ZAB, as 5 O2 molecules are consumed, how many zinc atoms, if any, must also be consumed? I don't like chemistry, and I'm not much good at it. But the thing you have to remember with the ACT is it will never ask you a chemistry type question. There are always questions that can really be answered. Not ever, but I mean, generally, they're not going to ask you something that's about chemistry. And I know how to answer this just because I've done it before. This is a repeating question. I've seen this question typed before. And that's why I know, and that's why it's so important to do as many official ACT questions as you can, because they do repeat. And this says, this is 5 molecules, right? We come up to the equation here. This says 2 zincs plus 1 oxygen goes to 2 ZN. 0. O. So basically, this is how you do these. This is just as simple as a 2-to-1 ratio, right? So this is 1 O2. If there was 5 O2, that means zinc would be 10. And that's as simple as it is. These ones come out to be just simple ratios. Why did it do that? So 28, we're looking for answer. I really have no idea why it's jumping like that. We're looking at 10, and that's J. Okay, last question. Suppose trial 1 was repeated, except at a current of 10 milliamps at 200. Okay, so trial 1, that's step 1, we have to find trial 1. Repeated except at a current of 10, so we have to find or understand what 10 milliamps is about. 200 seconds, find that. 3, and then 4 is find the volume of O2 reacted. So trial 1, we remember, was down here in experiment 1, and it's over here. So I'm getting rid of all that. Trial 1 is here. So we've found trial 1, we've done step 1. The second part, we're looking at except at a current of 10 milliamps. This graph doesn't tell me anything about milliamps, so once again, what does it mean? I just have to go back and read what the experiment says. It says that 3 trials were done at a current of 20, okay, and we only have 10. All right, so at 20, this is at 20 milliamps. The graph says the volume of CO2 reacted, so we know that's there, at 200 seconds. This is the third step. We have to find 200 seconds. At 200, or at 10 milliamps, it's 0.25. So the answers say, will it be less than 0.25, between 0.25 and 0.32, between 0.3, whatever. At this point, again, this is a speed test, I think it's common sense that the more electricity, the more voltage you're putting into it, or current you're putting into it, the more oxygen would be, volume of oxygen would be reacted. So if this graph is showing me what 20 milliamps is, and we only have 10, then I'm going to go that it's most, and it says most likely. It doesn't say exactly, it just says most. What's it most likely to be? What does common sense tell you it is? And that would be A. It's going to be less. There's less current going into it, so it'll be less than when it had twice as much current over here, and it was 0.25. So I'm going with less than 0.25, A.